Hello, welcome to the next section, Continuous Delivery Pipeline. In this section, we will first design different software environments and their infrastructures, then we will be introducing various kinds of non-functional tests. Moving ahead, we will be explaining different types of application versioning, and finally, we will complete the continuous delivery pipeline. Now we move on to the first video, Environments and Infrastructure. In this video, we're going to discuss different types of environment, their role in continuous delivery process, and infrastructure security aspects. There are four most common environment types: production, staging, QA, and development. Let's discuss each of them and its infrastructure. Production is the environment that is used by the end user. It exists in every company, and of course, it is the most important environment. Let's look how most production environments are organized. Users access the service through the load balancer, which chooses the exact machine. If the application is released in multiple physical locations, then the first device is usually a DNS-based geographic load balancer. In each location, we have a cluster of servers. If we use Docker, then that cluster of servers can be hidden behind one or multiple Docker hosts. The physical location of machines matters because the request response time can differ significantly depending on the physical distance. Next is staging. The staging environment is the place where the release candidate is deployed in order to perform the final tests before going live. Ideally, this environment is a mirror of the production. Let's look at how such an environment should look in the context of the delivery process. If the application is deployed in multiple locations, then the staging should also have multiple locations. In the continuous delivery process, all automated acceptance functional and non-functional tests are run against this environment. While most functional tests don't usually require identical production-like infrastructures, in the case of non-functional, especially performance tests, it's a must. The QA environment, also called as a testing environment, is intended for the QA team to perform exploratory testing and for external applications which depend on our service to perform integration testing. The use cases and the infrastructure of the QA environment are presented in the diagram. While staging does not need to be stable, the QA instance needs to provide a certain stability and expose the same API as the production. Contrary to the staging environment, the infrastructure can be different from the production, since its purpose is not to ensure that the release candidate works properly. The last environment is development. The development environment can be created as a shared server for all developers, or each developer can have his/her own development environment. A simple diagram is presented here. The development environment always contains the latest version of the code. It is used to enable integration between developers and can be treated the same way as the QA environment, but is used by developers, not QAs. For the purpose of the continuous delivery process, the staging environment is indispensable. In some very rare cases, when the performance is not important and the project does not have many dependencies, we could perform the acceptance tests on the local development Docker host, but that should be an exception, not a rule. In such a case, we always risk some production issues related to the environment. In many cases, deployment to the QA environment is triggered manually because it can have different life cycles from production. All environments need to be well secured. The most important requirement is to keep the production secure because our business depends on it, and the consequences of any security flaw can be highest there. In the continuous delivery process, the slave must have access to the servers so that it can deploy the application. There are different approaches for providing slaves with the server's credentials, and they are: putting SSH key into slave, putting SSH key into slave image, configuring Jenkins to store credentials, and the last approach is to copy SSH key to slave Jenkins plugin. Each solution has some advantages and drawbacks. While using any of them, we have to take extra caution, since when a slave has access to the production, then anyone breaking into the slave breaks into the production. That's all about environments and infrastructure.